Welcome to Build 2, where we go into all the little details about building this stuff. Now, if you haven't already, there is a fancy video with music and everything that shows what this thing is for, the drive behind it, the whole COVID counter type thing. And I assume that's what brought you here, but if not, you want to go watch that sucker real quick so you can see what this is all about. Otherwise, it's going to be kind of confusing. As you saw in that video, my wife was not happy with the first idea that we came up with, and I had all this video stuff ready to go. I pretty much had this video done per the old design with the little LED separated so you had sort of a line to break and activate this thing. But we had to go redo everything. So this video might get a little bit choppy as I try to put stuff together, but hopefully I can make it smooth enough to make sense. Now, I have to go into a bit of a disclaimer. I wasn't planning on having anybody have to solder anything. I had forgotten that this display was a buy and solder together kit. But it is. But hey, so much the better. You get to learn about soldering if you haven't already. But, like I said, a little disclaimer. This is the soldering iron I have had for 20-something years. And I have burned myself with it, I don't know, not really badly, but a little bit many times. And I've even done it more recently with my nice soldering station. You're working on something and you accidentally, whoop, touch something and you get a little burn. I've even, working on things over the years, working on a phone plug and the phone rang while I was touching it and I got a shock off of it. If you were going to play with electronics, if you're going to start down a hobby like that and you're going to be doing much soldering and you're going to be doing much wiring, you may occasionally get a little burn and you may get a little shock, even if you're being careful. So this is the disclaimer. If you're going to do any of this stuff, you got to take some personal responsibility, all right? If you end up injuring yourself, it's at your own risk. It's not me. So you can't say I didn't warn you that when you're messing with electricity, there are some risks with it. I think with hobby stuff like this, it's relatively low. But if you start doing stupid stuff, plugging into the wall and not listening to the warnings and stuff that are out there for it, yeah, you could end up with some minor injuries and who knows what. So if that kind of thing is going to cause you problems, or you're thinking that that's going to be my fault somehow, just end the video right now. So I really want to help people out and I really want to help them learn, but I'm not interested in any complications like that, all right? So the rest of you who really want to learn and you're willing to take reasonable responsibility for yourself, keep watching. All right, that's all I have to say about that. Let's dive into this thing and see what it's made of. All right, we have our display. This is that Adafruit display. It's awesome. It's a little kit that you get and solder it together. We have our Arduino Micro, and then we have our sensor. And those are really the only three things that you need. Now you notice these are put together with jumper wires. And when you get the kit that I put in there, any kind of jumper wires that you get an assortment that has both male and female. They call them ends on them. So we have for instance, this is a jumper wire with a male end and a female end on alternate ends. I'm not using any of those in this project. I guess you could, but for this, all of these, when you're going to direct connect them like this, is a female-female, because there are, oh, that isn't a female-female, that's another male-female. So the ones that are using here are female-female, that they can just go right onto the pins that are on the Arduino Micro, and they can go right on the pins that are on the Adafruit display. And we ended up using a little piece of header to connect these together, but they can also slide right on the pins of this. So this is really all you need to be able to connect this thing up, and then of course your cable to plug it into the computer and program it. But I highly recommend, especially if you're serious about playing with electronics, that you get a breadboard. This is how much I like breadboards. I have a whole bin that's just labeled breadboards and lasers, man. What else? What else could you want in your shop? So breadboards, they come in various sizes. This is the one that I used originally to lay this project out, but you can get them in all different kinds of sizes. I think this came in like a 3-pack. And yeah, they're not super cheap, but again, they're awesome. So we can take, and I think I know this thing well enough, I can just pluck these wires off and make it work. So what the breadboard allows you to do is just stick this thing in here. So these connections are on each side of this. They're all lined up, and then you've got power that you can run down the ends of it. It's really cool. So you can, let's see, how did we have this hooked up before? We rock this thing in here, and you gotta be careful, because you could break this board when you're trying to push all of those little pins in at the same time. You could snap something. So you kind of just got to rock it back and forth, work on it. And now any pin that we want to connect to, I can just shove a jumper wire in there. It doesn't even have to be a special jumper wire. It could just be a wire that I stripped that was the right gauge to drop in there, and boom, all of a sudden I'm connected to that port. These are the jumper wires that are made for hobby electronics like this. So if I want to connect to power or ground, like there's ground, I can just go connect to it and then run it over to something else. And of course, then I can take my sensor and I can stick it just any old place. You don't want to, if I line it up like this, they're all going to be connected to the same spot, but I'm going to turn it this way, and then now same thing. I can run a jumper into any of the holes that are lined up with each of those contacts, and that's how I get my connection to it. And then the same thing with the display. I'll plug this display in here, and if I put it right there, I'm not going to be able to reach any of the contacts. So I'm going to move up to that bottom row, and now I could put up to, I mean, shoot, how many holes do I have there? Like 4 different holes lined up with each one that I can just line up and connect to it. So I've laid out, I took a picture like this, and I'm sharing with you and put it on the screen now, the wiring diagram for this. All you have to do is look at that wiring diagram and use your jumper wires and connect to each one of them. So let's talk about Arduino for a second. This is an Arduino Micro, and it's micro because it's small. This is an Arduino Uno. It's a lot bigger. And yeah, you can control more powerful stuff with this, but they do essentially the same kind of things. So I want you to think about Arduinos. One of the most basic things you can do with them is just switch something on and off, like a light. So we turn on lights and we reach over to a switch and we flip the switch up and the lights come on, and we flip the switch down and the lights turn off. That's one of the things these are really good at doing. And I want you to think about like the light switch being here in this little chip, and many of these little contacts along the edge, depends on which ones, a lot of them can be set up to connect to a light, like a little LED or even something more powerful, and just switch it on and off. And you can set up all kinds of logic, like I want it to switch on when this happens, or when I push this button, or when a sensor sees something, I want the light to go on and I want it to go off when something else happens. But that's not all the contacts can do. You could also use them to power a motor and make it spin one way or the other, or maybe a little servo and control something. Or, like in this case, you can use it to control a display. And it doesn't have to be a really simple display like this. It could be some fancy graphic thing. But this is a great example, kind of like I said, that it's able to turn lights on and off with some of these little contacts there. Well, there are only so many contacts, and these have a lot of lights. So you think about a clock radio, digital clock radio, typically they have 7 segments, 7 little lights per character This is a special one that has 14 lights per character. And you think about 14 plus 14 plus 14 plus 14, that's a lot of characters. We don't have enough of these little contacts on there. Even if all of these could be made to switch lights on and off, there's not enough here to power all of those up. But Arduino has this really cool function that rather than each contact controlling a light, it has something called serial communication, to where you can think about it like a set of walkie-talkies. It's not quite that simple, but almost, where the board has a walkie-talkie and the display has a walkie-talkie, and rather than just saying switch one thing on, switch one thing off, it's like they're having a conversation, and it can basically say, hey, turn this one on to say 7, turn this one off to say letter A, turn this one on to do whatever. They can communicate a bunch of information in a really short amount of time, and that's what serial communication is. And all of the Arduino boards have that capability. They can do, there's more than one way to do it. This serial communication that this board uses is called I²C, and that's just, it's neat because you only need 2 wires to be able to do the to send that information back and forth. But that's all the more detail I'm going to go into it. Look at the wiring diagram. There are 2 wires that connect from pins 2 and 3 to these 2 pins over here, and then there's positive and negative. That basically everything's getting its power from the board, because we're plugging in this USB cable, and everything's getting powered from the 5 volts on that USB cable. So then you look at these, each one of the contacts is labeled. It's really small, you might need a magnifying glass to see it, but you look at those contacts and there's ground and there's power and the various inputs and outputs of the pin. So for this really simple project, we've made it really basic for you, showing you exactly where to connect the wires to. So that's why it's nice to have a breadboard, because if you hook something up wrong or you realize, hey, this isn't working, oh, look at that, I connected this pin. You don't have to desolder anything as far as those wire connections. You can just pull the pin and stick it into the next one until it works. And these hobby electronics, I mean, you can burn them up, but they're pretty forgiving if you just connect it to the wrong port. So, and like I said in the video, I still connect these things incorrectly when I go following the wiring diagram. I mean, as many years as I've been doing this, you'd think I'd do it right the first time. I don't. A lot of times I do, but I hook it up and it's like, why isn't this thing working? Oh, it's because of that. So don't get too frustrated when things don't work right the first time. You don't do that to yourself. Just realize we're all human and we all make mistakes. Try to minimize them. But when it doesn't work, just think, I wonder what mistake I might have made, or I wonder if there was something I didn't understand right. So by the way, this display, I think I mentioned before, is something that you have to assemble yourself. I'd forgotten that. It's been, we've had it around for so long playing with it, something I got from my son to play with. You buy the board, you don't have to worry about soldering this sucker on there, I don't think. It's just putting these, you got to put the header on there, and you've got to put these, the 14 segment dual displays on it. But it comes as a kit, you solder it together. Of course you need a soldering iron, you don't need a fancy soldering station. It'd be nice if it had a newer tip on it than that. I soldered a lot of stuff with this junky, cheapy soldering iron, but you don't have to listen to me on how to do this. Adafruit actually has a really nice guide on how to solder this thing together, and I'll put the link for that in the description down below, wherever I've got all the links together, so you can just go right to their description of how to solder this, because I mean, shoot, how many of those have they done versus me? This guy, these little infrared sensors, they've got power and ground, and then the output signal from this ends up being an input signal into pin 4 on this. Now it could be any one of the input pins, but when my son programmed this sucker, he picked pin 4, and that's kind of handy because it's right next to the those serial communication pins on there. So yeah, hook it all up per the diagram, and the next thing that you need to be able to do is get the program and load it onto the Arduino. So I'm going to call these wires up right now, and so we can do that next. All right, I've connected a bunch of wires per the diagram, and I already caught a mistake. I had a positive connected to a ground, but I didn't plug it in yet. I was just looking like, wait a minute, that doesn't quite make sense. So yeah, I am fallible, but I caught my mistake. Now, I'm going to test this with everybody watching. Plugging this into a USB 5 volt. All right, here we go. Let's see if Quint made any mistakes this time. And it's okay if I did. Let's cover our sensor. And it starts counting up exactly what it's supposed to do. So I connected it correctly. Now, something that didn't get a lot of coverage in the main video was that we wanted, in case this thing got tripped and it took you too long to get the soap ready, we wanted to be able to reset it really quickly. And so we come up, reset, you take your hand out of the way, and it immediately starts over. That was an absolute request that I had to have, and that was the one that my son was having trouble getting to work, and just had that moment of celebration when he finally got it working. So this is the code that I'm going to be loading up, but I'm also going to make the other code available if you want to break the LED off of there separately and make some kind of a little chain that has to get broken if you want to do more of that tripwire sort of function that I was so attached to that my wife wasn't a big fan of. We'll include that code as well. And feel free to get in there and play around with the code. If you think that this initial delay of when it's saying soap and then wash at that 5 seconds is too long, you can go on there and play with it and start messing around with the numbers. You can't hurt it. I mean, what's the worst you're going to do? The code doesn't work and now you got to download a fresh copy. Oh, wah. But you have the chance of being able to edit it and make it do whatever you want. That's one of the beauties of programming. Now, one of the reasons you might want to do the other mode where the light is pointing directly at the sensor is you could start doing some other really cool configurations, like having them on the face of the bottle to where they're pointing at each other, sort of making an up and down beam. And you know where I got that idea? On this soap dispenser that my wife had gotten for the kids years ago. Guess how this thing works? The LED is down here, infrared LED, and up here, it's gross, but what do you see up there? A little black infrared photodiode. And guess what? It's pointing down at this guy, so that photodiode, it's not totally immune to sunlight. In fact, I think that's why my wife got rid of it, because she had it in the kids' bathroom where there was a little bit of light getting in there and it kept triggering automatically and making a big mess. At least this timer isn't going to make a mess if it's sitting there cycling all day. But I think it'd be kind of cool if some of you want to reconfigure this thing. And yeah, there's a little bit more of a splash hazard doing it that way, but look at the soap dispenser. Of course, it's running on batteries, so it's all standalone. But either way, play around with the idea, come up, be smart about it, of having the sensor on the bottom and, the LED on the bottom and the sensor, the photodiode up on top, and you just come through and break the beam just by putting your hand there. I bet, how many thousands or hundreds of thousands of people bought this thing and had no idea how it worked, that when they were putting their hand under there, they were actually breaking a beam, just like the design that I was so attached to for this sucker. But enough about that. Let's talk about programming. To be able to talk to your Arduino, you need to download the Arduino IDE. And just click the link in the description, or I've got this Instructables project that I'm documenting everything. But yeah, go to this page and find your system, whatever it is, and download this software. Once you've got that going, and this is the first time I've got this running on my machine with this particular Arduino, So this should challenge me to work through some of the steps that you're going to run into. So you open the sketch and it automatically throws this setup and loop in here that I don't want to get too much into the details, but every Arduino program, or what they call a sketch, is going to have this setup portion where it's just kind of, okay, it needs to read through this part for the thing to work, for part of the program to just know what you're doing with it. And then the loop is just what you'd think it would be. The word void is not going to make any sense. You just ignore it. It needs to be there though. The loop is just what you would think. It's just loop. It's the part of the program that's sitting there running the whole time. So we're not going to use any of this stuff, so we've opened the program and here it is in our sketch window. So the first thing we're going to do, I've got the Arduino micro plugged into one of the USB ports, but this thing doesn't know where it is yet. So we're going to go, let's see, where is it? We go to Tools, and the first thing we need to do is come down and pick which board we're working with. Now, I talked about the Arduino, but this thing is really set up around the Arduino Micro. I keep wanting to say Nano. Arduino Micro. The last board I had connected to this computer was the Uno, so that's where it's showing. But we need to come over here and go down to the Micro. So we click on that. So now we say we're telling it to do the Micro. And there's an order to this. I had to have my son remind me what the order was, but it's really from top down. It's really handy. Go to the Tools, go here, select the board. The next thing you do is go to the ports, and hey, look at this. It shows up, which you'll have multiple ports listed here, but you see the Arduino Micro, so you want to select that one. And then the third thing you do, like I said, from top to bottom, that we set the board, we pick the COM port, and now we do this get board info to see if it's working. And hey, we got our little window popped up, and this is how we know that the Arduino IDE is actually able to talk to the board. So we are good to go. Now, the way that I chose to document the sketch is on the Arduino website, and I've created a link. So if we go to the video and scroll down in the notes, let's see, link, Arduino Sketch right here. So you want to click this link and it'll take you, this is so cool, it's going right to this really nice editor setup that Arduino put in place so that I can make a sketch. I have to log in and make an account to do this, but you don't. You can just click the link and now just select all of this, just get everything. Just select the whole thing, copy paste. So I'm going to do a Control-C, and we're going to go back to our Arduino IDE here. And I don't, this stuff is already in the void setup and the void loop are already in the other program. So I'm going to select it and delete it. And now I'm just going to, oh, I left something there, V. So this whole thing is completely clear, and I'm going to paste in, boom, the code. So there it is. That's my son's code that he set up, and we are ready. This check mark here, we don't have to do this, but let's do it. This is, and you see that it says verify right there when I hover over that checkbox. This just verifies that the code works, that you didn't mess up any little characters in that copy paste. So I'm going to hit verify. Oh, this is excellent. Good, because I wanted to work through this. Save sketch folder as, so it wants to save this to your computer somewhere, which is, it's fine. It's not doing anything. And it's coming up with today's date, but I'm just going to call it handwash1. Did I spell that right? I did not. Handwash1, and we hit save. Compiling sketch, it says done compiling. So it worked. It didn't give us any errors. Now if I came in here and let's say I hadn't cleared that last little V, let's just put that back in there and see if I can verify. See, and it gives you some hint in here, stray hashtag in program, and it's even highlighting it up here at the top to say this something about this line isn't working. So that's kind of cool. It's a little bit of a check before you ever try to load it up. So I'll hit verify again. Done compiling, it verified just fine. Oh, and one other thing I almost completely forgot that is really important. It's going to hang you up because I've already loaded this stuff up on this computer previously. There's something in Arduino called libraries, and it's what helps you not have to do a bunch of nitty-gritty little programming things. Someone has already figured out the best way to send commands to this display that we're using. So we need to go into Sketch, include library, manage libraries, and there are 2 libraries we have to get in here and get. In the Instructables, I have the 2 things that you need to load up. This Adafruit GFX library, so I'm just going to copy paste right in here, and here it is. Adafruit GFX library installed. Because I have that installed, it worked. If you don't, you won't have that installed initially. So you need to come over here and click the install on anything that it asks you to come with it to include it. The other one is this Adafruit LED backpack library. I'm literally copying and pasting right out of the Instructables. Just delete Adafruit LED backpack, and here it is. Also shows installed. So you need to open this one up and install it. Install both of those, and then you won't get any error messages. This is, like I said, it's a bunch of programming in the background that makes it so we don't have to fill our sketch with a bunch of details on how to drive that LED backpack. So it's really helpful. Later on, if you get really into advanced programming, you can dive as deep as you want to into these things. But I choose to let the experts on those particular parts figure out this stuff, and then I can use it to do cool projects. Now, we're already plugged into the Arduino, and here's where we go upload. So upload is the direction of taking it from the computer to the Arduino. So let's hit upload. It says uploading. Takes a few seconds. Done uploading. Now, because the thing is plugged in, let me have a look at it. Let me verify that it is indeed working. Once you've done this, the thing should start working. And yeah, it's working for me, just moving my hand over the top of it. So there you go. That's all you need to know. If you want to start messing with the program, you can see my son actually put some pretty nice notes in here for adjusting your time. Set this to the seconds you want. Please note that maximum is 99. So you can, it's kind of cool. Get in here and mess around and play around with it. But yeah, there you go. That's all you have to do to you get the thing wired up. You get this, go find the sketch online, paste it in, and now the really cool thing is you're all set to start playing with your Arduino and doing other things with it. So that's pretty cool. So congratulations, if you've gotten this far, this is amazing. This is really where my goal was for all of you, to just program an Arduino and hook up some stuff to it and get it working. So with this thing just plugged in, powering USB, this is how it should work, and kind of like it was at the beginning of the video, just sitting there. Now, of course, we don't want this thing to get wet. If you're actually going to take the next step and start using this thing as a hand wash counter like it was intended, we don't want to be spraying this thing with water. It's just not, it's not a good thing. So we need to put it inside of some kind of container, and of course I went for the 2-liter bottle thing. But here's something you need to be aware of. Here's a piece of a plastic bottle I just cut up, and it looks clear to us, and in fact it's clear to infrared as well. If I sneak it, oh, look at that. So watch the little green light down here. When I'm all the way on the surface, there's no way for the light to reflect back. But if I just come a little ways away, and depending on the direction of the curvature of the bottle, so it looks like the best bet is just to be right up against it. If I pull away, then all of a sudden we're stuck. You can see the green light is on and it's stuck on this reset mode. But if I come right up against it, then it's able to work, and I bring my hand over the top, and now it can do the same triggering that the normal operation that we want it to be able to do. So if you're going to go put this inside the bottle and use it like it's intended to be used, to keep water off it and everything, you need to mount the sensor, this whole module here, so that, see if I can sneak it right over the top without triggering it. And, hey, there we go. Mount it so that it's right up against the plastic. That's your best bet to make sure that it's not gonna just be triggering from seeing its own. Let's move away. It's just seeing. It's sending infrared through it, no question, but it's also seeing its own reflection. It's bright enough, it's intense enough, and sensitive enough that it's seeing its own reflection off the inside of the plastic. So be sure, however you put it in there, it's right up against the plastic. That'll be your best bet. And of course, yeah, as we saw, ideally you don't have any outside light getting to it, and you've got this little adjustment. It's nice to be able to touch that adjustment in the assembly. So if you can set it up in a way that you pull the lid off and be able to access that screw directly, put it right back down so that you can tune it for the lighting conditions where you're actually using it. That's going to be your best bet as well. But to be able to put this thing in there, we need to switch from these kind of jumpers. Let me just go ahead and unplug this thing. We need to switch from the kinds of jumpers that have the male and the pin sticking out of them. We need to switch from that to the female on both ends. Let's not look at that for a second. So the female on both ends, that way we can take the display and the module and this guy and just plug them in like I had it at the beginning of the video and drop it back inside of the bottle. But the connections are all the same. You just connect it up to where it matches that same wiring diagram that I gave you. Now, in order, it's a little bit tricky that I used. You've got to be able to connect some of these. The power and ground, you can see, have connections on there. We ended up, you can do this however you want. You could strip the wire and tie them together. You could take little bunches of wire and stuff them in there. We ended up taking a piece of this header that you can buy in little strips like this. It was just, hey, why not? We cut off a little piece of it and just soldered right across the back face. Actually I did lay a little piece of wire across that, is what we did. Laid a piece of wire across the back of that and then just stuffed. That way anything that we connect is just connecting all of those together. And let's see, what are those? Yeah, looks like power. So those are all the power wires. And use whatever colors you want. These are just the random wires I had left around. So we hooked it up like this. Also, to get that 2-liter bottle to come apart and go back together okay, of course I used a little X-Acto knife. Any kind of a utility knife will work fine for splitting it apart. Grab some scissors if you need to clean up that edge. And it does matter whether you go clockwise or counterclockwise. It works way better depending if it's a right hand or left hand pair of scissors, so pay attention to that. But the way that the 2-liter bottles are made, expanded inside of mold, means that when you put heat to them, they can shrink back down. So in order to make the top slip over the bottom and sort of nice taper fit there, you want to take some heat and apply it to that bottom edge. And of course I just grabbed a soldering iron. It was handy. I've tried a heat gun or just warming it up. I've seen some people take them and just take that leading edge and hold it into onto a pan on a stove or something like that. But just give it just enough heat for it to start to curl in, and then the two should nest together really well. Now, even though we've got this thing set up with this nice taper on there. This is kind of like shingles on your roof that as water splashes this thing, it's gonna run down the face, and it's not gonna get back up inside of it unless you like had it tilted upside down. So that there's a reason I cut it the way that I did and shrunk the bottom part. And when we set our wire, if we're going to have our power source outside of the bottle, as long as we do it like this, water could get on this cable, and what's gravity going to make it do? It's going to drip down to that cable, and as long as the cable comes back up, you'll notice this on people's houses, that the wires, if they've got power coming in overhead, the wires often make a little droop like that as they come out of one housing and into another outside. And of course that's for weather, for drips. So as long as this thing is upright and the wire is coming out like that, then it's relatively safe not getting water inside of it. But you've got to be aware, if you've got, I mean, shoot, you never know. Little kids that are just spraying water everywhere. I mean, I know when my kids were little, they liked putting their hand on the bottom of the faucet and watching the water just spray in every direction. That's not a good application for this. You're asking for trouble. If that's what's going on in your house or your home or wherever you're living, and you expect this thing, I would not do one of these next to the sink. You don't want to mess with that. And that's especially, like, this is a pretty good sized battery pack, and it's supposed to be water resistant, but you still have a plug here that you're plugging into. You don't want that getting wet. So you got to be smart about this. You want to keep this thing as dry as possible. And then, yeah, in my house, I plug this thing into one of these, because the battery, if I have it in a battery pack, it's eventually going to go dead. But I plugged it into this, and then I plugged this into the wall. But in the United States, where I'm at, for the last, I don't know how many decades, it has been electrical code. It's required that in garages and bathrooms and outdoor receptacles, that they all be GFI or GFCI, ground fault circuit interrupter protected. And I'm going to mention it again. There's a fantastic video describing going ELECTROBOOM. Don't be fooled by his silly antics. That guy is brilliant. He is absolutely brilliant. And has a fantastic video on GFCI up there in Canada. So I'm putting a link to that video. You go watch that so that you understand what GFCI does, what it's about. That if you know, it was put in place because people were dying from electrical accidents in bathrooms and kitchens and outdoor things where things were getting wet. So it became code requirement. However, that doesn't stop a homeowner, if you don't have a brand new home, or if let's say your home was made after those codes were put in place, but some other homeowner went in prior to you and switched something out, or maybe the electrician didn't get it right building the house, and maybe just because your house is newer and you live in an area that would require those codes, doesn't mean that your receptacles, your outlets in your bathrooms and kitchens and next to these sinks is necessarily GFCI, GFI protected. It should be, but you need, before you go install something like this, this is your responsibility to make sure that it works. And it doesn't have to be like that receptacle that's next to the sink may not necessarily have a little reset test button on it to be protected. It just has to be downstream from a GFI, GFCI protected outlet to function. And to say, I'll let you go to these other videos to learn about that stuff. But I know for me, the way that I test that, I go test the the receptacle that is upstream and hit the test button, and it should shut off the one that you're using. So that's something they recommend, testing them frequently to make sure it works. So make sure that's your responsibility to make sure if you're going to go plug this thing in to anything other than a battery, and even if you are a battery, make sure it stays dry. That if you're going to go plug it in, that it is a GFCI outlet / receptacle, and even then, keep the dang thing dry, okay? Okay, I think I covered everything you need to know to do this. And yeah, check out the Instructables, check out all the links online to all the components. So again, I'm Quint with another one of my builds. Thanks for watching.